Welcome to this tutorial. Today you're going to learn which development tools to use if you want to develop your programs, create your own programs under Linux. Most of us have learned to develop our software programs in Windows using, for example, Visual Studio, which is a great compiler and debugger. But when you do most of the EDA development things, you do it under Linux. So we want to learn which kind of tools we have to develop our software programs in Linux. So the first thing we have to do is connect to our Linux machine. We saw in a previous tutorial how to set up that connection with Sigwin and Xwin. So in this case, I just connected SSH to my Linux machine, and I see like some C files that I've already created beforehand. So the most important thing is to create something in the Linux environment, the program, the software program, is to obviously the C program in this case, and a Makefile. Now, when we develop C programs in C or C++ or Java, the first thing we need to do is a text editor, and the most popular text editor in Linux is Emacs, or in this case xemacs. And the advantage of it can be customized. You have tools, you can download packages. For example, you can see here on the screen like all the different packages you have for development for different programming languages to highlight the syntax and so on. So you can customize it to the way you like. Now, it's not as easy to use in the very beginning because the shortcuts are different and so on, but this can be all customized. So the learning curve might be a little steeper at the very beginning, but once you understand how Emacs works, it's extremely simple to use and very useful. So most of the software, the entry, is written in Emacs, or in this case xemacs. So you see here a piece of C code that I wrote before, and you can see how the syntax has been highlighted for the C code. You can search for text, you can search for regular expression, you can substitute, you can do everything you can do with a very powerful text editor with xemacs. So the first step is to write your C program with any text editor. In this case, I would recommend your Emacs or xemacs. Now, once you have edited, you have created your source code, the next thing is to compile it and see if you have any errors or not, and create your exe file. So for that, you need to create a Makefile, and a Makefile is a text file with the instructions that in order to compile the program. For larger programs, you have a lot of dependencies, you have a lot of options that you can specify and so on. So in this case, you have to specify the source code, the header files, the name of the output file, the binary, and different options. And you can. The good thing about a Makefile is that you can easily generate different types of version. For example, a debug version of your program and the final version that you wanna release. So you need to understand how the Makefile works in the syntax. That's extremely important when you do development in Linux. So the best thing is to actually Google Makefiles and the structure. You can see an example on the screen, and as I said, you have different versions. So now Linux has an embedded tool called Make, that when we type in make, it will look for a file called Makefile, and it will then follow the instructions if there are no syntax errors and compile that file. If you say make and you do not have a Makefile, then you have to, the Makefile actually has a different name. You need to type make-f and the name of the Makefile. So if you don't have a Makefile, if you change the name of the Makefile, if you want to debug things, you can, as I said, like you can need another version of the Makefile with a -g, and you can also have if-def statements and show here for different versions of the program. So if-def, and you have whatever variable you declare or pre-compiler directive, you can specify that in the Makefile with a -d and then the pre-compiler directive. So then the compiler will actually compile that part of the source code in the pre-compiler directive. So you can just type make, and it's now compiling, it's calling GCC in this case. And it's compiling, it has just created the exe file, the binary to execute your program. So then you can execute the binary just compiled. So like we wrote the program with Emacs, we create the Makefile, and now just calling make, we compile our binary file. And we're executing the program that we just compiled. Now the next thing that you might want to do is you might want to debug the program. So what kind of tools do you have in Linux to debug? In this case, you can say make clean to clean all the object files and everything. You can say type in make all or make debug, depending on the kind of version you want to create. If you say debug, as I said, that the source code in the pre-compiler directive will be compiled, will be taken into account by the compiler. If you say make all, then the -d debug will not be compiled, and then it will be ignored basically in the new version that we just compiled. No? So you can say make clean again, you say make debug again. Now we want to regenerate the debug version of our software, and now we want to debug the code. So you can use GDB, which is the standard Linux debugger, but GDB is a command line debugger. So what most people actually use in Linux is DDD, which is the graphical user interface of GDB. So if you type DDD and you compile the software with the -G version on for debugging purposes, it will then open the source code debugger that you see on screen, and now you can see we're just sizing the window, and you can see the source code, and you, by right clicking with the mouse, you can insert breakpoints wherever you want in the source code. So you have different windows. You have the source code window, the command window, and you just type in run, and then the options, the arguments that your program might accept. In this case, our program accepts a few arguments. So you type the arguments in the command window, and it stopped. It just hit the breakpoint. Stop there. You can open the display variable window, the debugging, and now you can just click on any variable, right click, and select display, and you can see it in our display window. You can see the variables. If you have a linked list, you can see the data structure, you can see all the values of it, and now you can step through the source code, so you can do a software debugging for the compiled program. So this is the most widely used source code debugger for software in Linux. So then you can do everything you can do with Visual Studio in Linux, and it's all free. And for larger designs, when you want to compile things, then a Makefile is the most useful thing. That's the best thing you can invest is to learn how to write properly a Makefile. So now we're exiting the debugger here, and you can see again the source code and our Linux environment. Well, I hope you enjoyed this tutorial. If you have any questions, please drop me a line. I'll be happy to answer them. Thanks very much for watching, and stay tuned for more videos. Thank you.